Hey, this is a quick video showing how to search CloudFormation. So what I'm going to do here is I'm going to search. Okay, so now I have a couple of options here, the REST API, the method, deployment. A lot of ISC frameworks are going to take care of this for you, but let's just jump into the REST API part. And so how I would go about reading this documentation, no matter what the service would be, they follow all the same pattern. So the first thing you get is kind of the syntax here. Each one of these are clickable and they go to the different sections that talk about what they actually do. Some key things to pay attention to is that, for instance, if we look at the name of the resource, this will be the name of your REST API. You can see that it's required, but it's conditional, so that means it's sometimes required, sometimes not. And then they have a type of string, so it's going to tell you what actually needs to be put in there. Down here you can see this is a map of strings for parameters. Down here you can see that the policy is JSON, and the tags is a list of tag. So for instance, let's focus on the name here. And you can see update requires no interruption. So this is the other key piece of information. Some fields for CloudFormation require you to tear down the entire resource. So for instance, if we were looking at AWS Cognito, they have a parameter that where it's basically requires teardown. So if we click on this, we can see what these mean. So you can see no interruption here. So for instance, the name that we just looked at, some interruption, and you can see replacement. So things that need to be replaced, like for here, if you change the engine property on an RDS database, you'll have to tear down the resource and redeploy it. And that makes sense, but it can be tricky when you run into resources where you didn't know that field was actually going to require a replacement, like with Cognito. And if you weren't expecting that, it can be kind of, late in the game to figure that out. So it's always good to kind of scan this and see the resources that you're using and building and the parameters or the fields that you're using. Are any of these going to cause issues like downstream? The next big section that I want to cover here is the return values. So with any CloudFormation resource, you're going to get most likely a ref. This is what's called an intrinsic function for CloudFormation, and then a function get at. So the ref here, this is like reference to type of thing. So we're saying like reference the REST API. So as it says here, this will be the logical ID, and there'll be an example of that down here. For instance, in this case, this is the logical ID, my REST API. And so we say ref colon and then say my REST API. And what that'll do is it will return back the REST API ID. So that would be like here, A1BC. And so you'll see this as well if you look in the AWS console for API Gateway. You'll see that each API that you create has its own ID on the AWS system. And so what this will do is it allows you to pull that value back. A lot of times you'll need this, like if you're using serverless framework, you may need to import this into a different service to reuse the same API Gateway endpoint for multiple services. So the reference here is going to do different things depending on what the resource is. Some of the references will give you back the logic or the ID. Some will give back a name. Some will give back an ARN. Some will give back a URL, right? And so they can all be different. So you really want to look at what the return values are. And the point of this is that we're trying to stitch together multiple resources so that they work together. And ideally, what that looks like is, we might have one CloudFormation stack for API. We have one separate CloudFormation stack for our Lambda functions. And the reason why we would do that is because we keep isolation. And how we might be able to pass these values back and forth would be through a concept called imports and outputs. And so we'll cover that in just a minute, but continuing here, what we can do is we can basically reference the API in our first stack, and then we can output that value, and then we can import that value in our Lambda stack, and then the Lambda stack can make a reference to that API ID, and now everything can work together. And then these two stacks can be deployed independently, and you don't have these like coupled nature of it. And a lot of times when we think about, legacy systems or things like that, when it comes to coupling, why that can be really bad for CloudFormation, for instance, is that if the API gateway part needs to be modified, maybe it's okay to have the Lambda function attached to it. But if you have 10 different services and maybe they're split up into separate repositories, right? So now we have 10 repositories and then we have a shared resources repository. Now it becomes a lot more tricky because if we have to redefine that API gateway with the Lambda functions each time, we end up having 10 different APIs. Or we have one repository for shared resources that has the API in it. We're using outputs and imports. And so we output the API ID and the shared resources, and then in all 10 of the services with the Lambda functions, which are covering different domain-specific stuff like account or user feed or things like that, or billing. In each one of those, then we actually import that API in there, as well as any other shared resources from our shared resources repository. And now things are very decoupled, and it allows multiple teams to be able to reuse the exact same stuff. So for some clients that we've worked with the serverless guru, we'll have 120 plus applications where they're all, which a lot of them, maybe 30, are referencing the same API because they're all reusing that single API endpoint, but there's multiple teams all working on separate repositories, on separate services that all come back to the same API. So it's very interesting, and it's possible with different deployment frameworks, depending on which one you use. But that's some of the power of what you can do with these intrinsic functions. But not only that, of course, when you're writing this automation with infrastructure as code and with CloudFormation, values like this reference are going to come in handy because you'll have another resource like the method, for instance. So if we open one of these up and we look at the method, so let's look at integration. It may have a field here for the REST API ID. Let me just double check and see. Yeah, so do you see how there's a value here that says REST API ID? So this is the ID of the REST API. So if we switch back here, that's how we can use this reference. So we create this initial resource, but then we want to create a method on that REST API. And so then we need to get the ID value of that. And so how we do that in CloudFormation in an automated way is we use the reference value here. So we say ref colon my REST API, and we pass that as the REST API ID in this field. And you'll be able to see that down here most likely. So do you see how it says REST API ID and it has a exclamation mark reference and then my API? That's the same value as the my REST API here. So that's how these things kind of fit together. And then what you can see here as well is that this API gateway method requires a resource ID. And then you can now see another intrinsic function called Git At. So this is like Git Attribute. And you can see that it's pulling my API and then root resource ID. So if we look back at this example here and we go to the return side, return values, and in all these CloudFormation pages, you can actually search for return. And it'll pull it up. And you can see here that for the API gateway method itself, if you pass reference and you pass the mock method name to ref, it's going to return the method ID. And you can see an example of that here. You can also see that it doesn't have a get attribute aspect to it. So if we flip back to this one, you can see there's a function get at as well. So what the function get at attribute does, it allows you to grab, as it says here, a specified attribute of the type. Here it's for root resource ID. So the first argument when you use function get at is the name of the logical ID, which is my REST API, and the second one is root resource ID. And so what this looks like is, if we flip back to the examples over here, you can see function get at my API root resource ID. In this case, this is defined with a JSON file, and this is a YAML format for doing it. So it's the same thing, the exclamation mark versus this kind of broken out structure with JSON. You'll see some people use the exclamation mark and some people do more of like a function get at and then have like an array format similar to this. But yeah, that's how these work. It basically just you create a resource in CloudFormation, and then the intrinsic functions allow you to pull values from it and make some modification and do things. So the other concept I wanted to touch on, which I brought up a second ago, was the outputs. So we can search for that. Maybe I have it up here actually. Okay, now we're looking at outputs here for CloudFormation. So one thing that I want to point out here, high level outputs, your stack outputs a value, another stack can read in that value. An important note here is that as it says here, CloudFormation does not redact any information you include in the output section. And why they label this is because you could create an AWS IAM user And you could also create an access key and secret access key, which gives admin access to your AWS account. And you could output that value in outputs. And then anybody that has access to your AWS account could then see the CloudFormation console if they have that permission, and they could see the AWS secret and access key. And of course, if you're also have any terminal prints or anything like that, you could potentially expose that variable in a lot of different places that you're not fully tracking. And so definitely don't put things like passwords in here or secrets as it says, and also be very careful with using like an AWS IAM user secret and access key. Like this is a problem that we sometimes face when we're like almost automation consultants as well at Serverless Guru, as well as being like serverless consultants. We help a lot of companies build this type of stuff. And at some point, there's like this line that gets drawn of like when it comes to manual processes versus automation. And one area that I've felt more comfortable with personally is allowing somebody at the client to basically create their own. We'll use an AWS IAM user and create that with CloudFormation. But when it actually comes to creating the access key and secret key, we'll sometimes put that back onto the client to have their internal security team potentially create that resource or that access key on top of the user manually. And so that's kind of this like trade-off, because of course we want to be able to have the ability to create AWS IAM users, but being able to create access keys on top of them and having that exposed to the CloudFormation console. A lot of times people don't realize what they're giving access to. And so, yeah, that's just like one thing that I try to avoid, is that if I'm ever working with an AWS IAM user and outputs, I try not to put like sensitive credentials in there. And I would recommend that to other people as well. And if you are doing that, then just make sure that you are fully aware of all the other users that are inside the account that have access to CloudFormation and different resources like that, and that they're potentially scoped down a little bit more. All right, so the output section here, we'll just scroll down. The syntax here kind of gives you an overview of it. The output fields here, a little bit more description, so definitely look this up. The part that I'm going to look at is the examples. So for almost every resource, there's going to be an examples section. A lot of times when I'm writing CloudFormation, I'll just jump to the examples section. I'll just kind of copy one of these and I'll just paste it into a template and I'll start modifying it from there. This allows me to kind of get a jump start. Also, of course, Googling and saying, I want to build a HTTP API with AWS, and I want to use serverless framework or architect, or I want to use AWS SAM. How do I do that? Is there any template examples? And I'll Google that as well and see if I can find anything to kind of source and just kind of get a jump start. So here you can see that there's a section here called outputs. You can see there's a logical name here of, let's just focus on this one actually, called instance ID. There's a description and there's a value. And there's also something called an export name. And so you can see this here, export name. You can do this where you are just kind of outputting these values. It's good for somebody that's looking at the CloudFormation console, kind of reviewing it, just to see like what these values are. The way that I would do it is I would have this section here where in this case, let's say we have the stack VPC, this is our logical ID. We have a description, this is optional. We have a value, which is required. And you can see here we're using a reference intrinsic function to the my VPC resource. And then we're saying export name. And then there's another intrinsic function here called substitution, basically sub. And what it does is that it's going to change out this $, AWS stack name. It's going to change that out automatically. And so if you change your stack name, let's say it's, I call this one my super vendor 123, and that's the name of my stack name, and I define that when I'm making the CloudFormation deployment. And then I go back later and I want to create a my stack, 123A, 123B, 123C, or I want to create a my stack-test, my stack-dev, my stack-prod. I can change that, and then I can use this substitution intrinsic function here to then swap that name in, and that's going to help a lot. But to be able to have that scenario that we set up earlier where we have the shared resource repository, which has the API defined or the VPC, and then we have other Lambda function services that are actually consuming that, to have that kind of separation, that decoupled nature of it, we'll use outputs here. So we'll output the VPC ID, and then we'll import that into our Lambda function services. And so this is a good example of this because in a common case, your Lambda functions may have to be part of a VPC. And the reason why they might have to have access to your VPC is because the Lambda function may need to talk to an RDS database that's in a private subnet. And so in that case, then you would want to output, you want to have a VPC defined in your shared resources repository, and then you want to output that value so that all the 10 Lambda functions that need it can then import that value in. Then depending on the deployment framework, they'll have some type of fields for the VPC inputs, and then you can put that there. Yeah, so this is the overview here of how to read CloudFormation, how I would go about doing it. Just to give an example about like what this looks like again, let's just look at a random resource. I get a requirement from a client that says, hey, Ryan, we want to use, let's say, Cassandra, right? So I'm going to click on this, and I can see that there's two resource types here, key space and table. So I'm just going to start with table. I can see the syntax here. I can see some different fields here, billing mode. So I might scan over these just to see what makes sense, table name. And then what I'll do is I'll scroll down a little bit further, and these values are very helpful, but sometimes I'll just skip over the properties and I'll go straight down past the return values as well, and I'll look at the examples. And so now I'll look at this and I'll go, okay, I'll just copy this part, my new table. I see a key space name, I see columns. And then what I'll do is I'll go back and I'll look at, okay, what is the key space name? So I'll search for that. And then I can read about it. So I can see that it's the key space in which to create the table. The key space must already exist. Okay, so that's good to know. And when it says that, the key space must already exist, what that tells me is that this key space was the resource that we saw before. So you can see here there's a key space and there's a table. So that's how the dependency structure in here works, is that we're going to create a key space first, and then we can reference that same name for our Cassandra table. And going back down even further, we can see here we got my second table, we've got key space name, we have table name of employees, we have and this is an area too, with a key space name, this is where we might use an intrinsic function for reference. So if we go back and we look at the key space and we go down to return values, we can see that reference my new key space name, or my new key space, let's see what it returns. It returns the name of the key space. So instead of hard coding the name of this key space, like let's say we call the key space, my-new key space. Instead of hard coding that inside of our Cassandra table on this line down here, like you see how even AWS is hard coding it in their documentation. Instead of doing that, and they're doing this for a reason, they're doing it because they're trying to limit how many resources they have to show in one single screen. But what I would do here is I would have !ref, and then I would have the logical ID of the key space resource, so I wouldn't have to hard code this value as my new key space. And instead, I can make sure that if at any time I change the key space resource with a different name, it will automatically change the Cassandra table key space name. And then moving forward, table name, critiques that I'll make as well is that you can see that all these values are not stage specific. And so that would be something that, I would critique here. They're trying to limit, of course, how much they're actually showing on one screen. That's probably a topic for an entirely new video. But when it comes to CloudFormation, it's very important that you have multi-stage, multi-stage values for all of your different names, especially if you're doing testing and things like that, and you have developers that might cross over. The idea behind CloudFormation is that it's an exact replica of your test, dev, and prod environments. Maybe there's minor modifications around the exact size of let's say a database. Production might have a gigantic database or a cluster. Dev and test might just have a single database instance. But in a lot of cases, you actually want to mirror every resource because it allows you to test as if it was in production, so you don't have things happen downstream, which would be unpredictable. And so these are exact replicas, or they should be. And so in that case, if we're deploying multiple stacks into the same account, but they have the exact same CloudFormation name or the exact same resource names, they'll cross over, and what'll happen is the CloudFormation will actually break. And so that's why it's a very important concept, which isn't always upfront when you're actually working with CloudFormation, about doing multi-stage deployments. And so that's just kind of a best practice that you want to be aware of. And they may not have it in here just because of the size of the documentation. They don't want to put everything in this one spot. But yeah, so moving forward, then I would look at partition key columns, and I would look and see what makes this up. So let's search for that. Here you can see it's an array of columns, And so what that tells me is that there's going to be some specific information I need to follow for this. So if it's a list of columns, that means that it's an array of column, and that's an object. And so if we click on this, we can see this is an AWS Cassandra table column. This is the syntax here, column name, column type. You can see some values here, like both of these are strings. Okay, so now I know that I can call the column name, address, and I can say the column type is string. Yeah, so then moving back to the example, move down to clustering key columns, and I would go back again, search for it, go through the different documentation on it. And why this is so critical to just jump in here and just copy this and then just paste it in and then modify it is that it saves a ton of time. Like, we don't have to worry about did we get this exact syntax right here, and then we can go, okay, I only need one regular column, so I'll just delete all of these. And I only need, I don't need clustering key columns, so I'll delete that. And also, maybe I need the partition key columns, but that's it. And that's a better way to go about it. Something else here is that you can choose billing mode. And so let's see, a lot of things now have a various different kinds of billing modes. You have provision, where it's like kind of read and write capacity, is similar to DynamoDB previously. But what DynamoDB did is it came out to billing mode where it's actually like on demand, and so it can scale up. So let's look and see. Yeah, so you have on demand now, so you pay based on the actual reads and writes that the application performs. So where this can be nice is that if you have a development or test database that's not getting a lot of traffic, you don't have to provision 5 read capacity or 5 write capacity or 50 read or 50 write capacity, because you're almost like a lot of times you're going to be provisioning for the worst case scenario. And when you're doing that, you can end up paying a lot of money for that. So on demand in like lower environments is nice. There is an argument to be made that if you are working with on demand, then it can scale up pretty dramatically if you start getting traffic to it that wasn't expected, or some type of DDoS attack or something like that. A lot of AWS services have protection around that, but let's just say that did happen. Provision mode, like let's say you have 5 read and 5 write, if that scenario did happen and did take place, what would end up happening is that your database would just break. And so in some cases, you may want that. You may be fine with paying an extra, couple of dollars or whatever that ends up looking like, just so that you can say, I want to make sure that I'm not going to pay any extra things, because obviously the on-demand mode, if that scales up, your cost is also going to scale up. So it's a very easy way to just say, I want on-demand. If I get traffic, scale it up automatically for me. I don't want to even worry about it. Provision mode is like you have to review consistently to see how the traffic coming to your application, to your database, is hitting, to see whether or not you need to increase the read capacity or the write capacity. But yeah, that's the overview there on that. So this has been a CloudFormation video. I know we talked about things like imports, outputs, intrinsic functions, how I would go about looking at a resource and actually starting to build with it. I've never actually built a Cassandra table or a Cassandra key space, but you can see how I just went about it. I'd be able to build one pretty quickly just because the documentation has a lot that you can pull from. And then past that, you just want to run it, right? You just want to deploy it. You just want to make progress on day one, and that's something that we try to keep in mind at Serverless Guru, is that when we start working on something, we want it to be deploying day one. We want it to be, if we add in this table section here, we want to deploy this, and we want to see it actually deploy, and want to see what it looks like in the console, and we want to really understand just that single piece, and then we'll move to the next piece and to the next piece. And a lot of times what you do when you're first starting to work with CloudFormation is you might overwhelm yourself, and you might jump way ahead of yourself, and you'll try to deploy 8 resources at once, and then all the different nuances that go into actually building these gets lost because you found a template online, you just deployed it, and you don't fully understand what the connections are or where things need to be modified. And if a break happens, of course, then you're going through like a needle in a haystack type of situation, trying to figure out, this partition key columns is not actually a array of objects with column names. It's column name, and I have an extra S on the end, and I just had to go through 8 or 10 resources to figure that out. So a lot of times when you're making the deployment, CloudFormation will give you that type of feedback, but sometimes it doesn't, right? And sometimes it feels like a black box in some cases, depending on what deployment framework you're working with or how the errors get actually logged back to you. And if that ends up being the case, it helps a lot to start small and then slowly increment the amount of resources that you have. So yeah, deep dive, CloudFormation. I know that I didn't jump into any actual local coding and show any VS Code of actually building these things, but I hope that this high level overview of how CloudFormation kind of like works in the intrinsic functions and how resources get put together makes things a little bit more clear if this is specifically something that you're looking into. Thanks. Bye.